Now we'll look at the last example. Here, a walnut grower is estimating from past records that if 20 trees are planted per acre, then each tree will average 60 pounds of nuts per year. If for each additional tree planted per acre, the average yield per tree drops by a couple pounds, then how many trees should be planted to maximize the yield per acre? And what is the maximum yield? So again, it's a good idea to identify what it is that we're trying to find. So we want to know how many trees should be planted per acre. And we also know, we want to know what the maximum yield is. So we'll be maximizing the yield per acre. And here, what I'm going to do is, you can set this up in a few different ways. I'm going to choose the one that I think is the most intuitive. Because in the prompt we have that the average yield is dropping by 2 pounds per additional tree, so it says for every tree over 20, I'm going to let X represent the number of additional trees that we have, because it'll be a little bit clunkier if we let it represent the total number of trees, because that second sentence's equation would get a little bit harder to write down. So instead, because that second sentence says that for every tree over 20 that we plant, the average yield is going to drop by 2 pounds, I'll just let X represent that number of extra trees that we plant. So X is going to be the number of trees past 20 per acre. And there's another unknown, which is the yield per acre. Oh, sorry, the yield per tree. So the yield per acre is what we're actually trying to maximize, but I'm going to let Y represent the yield per tree. And then the yield per acre, so that's yield per acre, that would then equal the yield per tree, which is what I'm calling Y, times the number of trees per acre. So if you want to think about this in terms of dimensional analysis, we're just sort of canceling the trees here, and we're getting the yield per acre. Okay, so yield per tree I called Y, and the number of trees per acre would be 20, because that was our baseline number of trees, plus X, the number of extra trees that we plant. So now we need to come up with an expression. In order to turn this into a function of a single variable, we need to come up with an expression for Y in terms of X. So let's think about what the yield per tree should be, so what Y should be. Now the yield per tree was by default 60 pounds per year, but for each additional tree that we planted, we lost 2 of those pounds. So the yield would have been 60 pounds per tree, but we lost 2 pounds for each extra tree that we planted. So Y can be written like this, 60 minus 2X, because that's 60 pounds per tree minus 2 pounds times the number of extra trees that we planted. So that's how we can write Y as a function of X. So that was the yield per tree times the number of trees that we plant per acre. So this product will give us the total yield per acre, and this is what we're trying to maximize. So I want to maximize this function, and again, I can leave it in this form and just start taking derivatives, but I usually like to try simplifying at this stage so that I don't have to use the product rule. And if I do that, then I would need to FOIL. So if I take the product of the first 2 terms, so the 60 times the 20, I'll get 1200. If I take a product for the outer terms, I'll get 60x. The product of the inner terms is a negative 40x. And then the product of the last terms is a negative 2x squared. And we can combine these 2 inner terms because those are like terms. So this ends up coming out to 1200 plus 20x minus 2x squared. So this is the yield per acre. And this is what we're trying to maximize. So now that we've found the function that we want to maximize, we can take a derivative to start applying the first derivative test. So y prime is going to be 20 minus 2 times 2x, which is 20 minus 4x. We can also compute y double prime at this stage if we wanted to. Y double prime would just then be negative 4. And this has negative curvature. Y is itself a quadratic function, so that means the graph is going to look something like this. So that means that the critical point that we find will be the place where the local maximum, the absolute maximum occurs. So now we'll start looking for the critical points. A quadratic function only has one critical point, but we're going to find it the same way that we would find it for any other function. We just set that first derivative equal to 0. So that means that 20 minus 4x equals 0. Solving this for x will give you an x value of 5. So this x value of 5 represents a critical point, so the picture will look something like this. We know that the second derivative for y is negative 4 everywhere, so that means that the picture has negative concavity, and therefore 5 represents a local maximum. So this is our local max, and now we can use this information to address the questions that we had at the beginning. The questions were, how many trees should be planted per acre, and what is the maximum yield? So maybe let me answer these in reverse order because we found our x value. So finding the maximum yield is pretty easy. All that we need to do is write down y evaluated at 5, because 5 by design was the x value that maximizes the yield. So if I plug in if I plug in 5 into the function y, then I'll get 1200 plus 20 times x minus 2x squared. And if you plug that into a calculator, what you'll end up getting is 1250 pounds per acre. So that's the maximum yield that we can get. And then lastly, the other question was, how many trees per acre should you plant? And this one is just a little bit tricky. Remember that x was the number of extra trees over 20. So if we're planting, if we're planting 20 plus x trees, that was our number of trees per acre, then the number of trees per acre that you should plant to attain this is 20 plus x, which is 20 plus 5, which is 25. So in order to maximize the yield, what should be done is you should plant 25 trees per acre, and that maximal yield